Hi guys, here is your video for today's lesson. So still working with within our geometry unit, we are going to chat a little bit about the Pythagorean Theorem today, which is really this really awesome theorem that you'll use and sort of hopefully forever associate when you talk about or when you think about right triangles. So I'm going to go through and sort of annotate these notes, and you should have this paper in front of you, and I'm hopeful that you will do the same. When we're finished, I'll have some practice for you to work on, and we will connect about these the next time I see you in class. So we're talking specifically about right triangles, and we know that right triangles have one right angle. And I know that a right angle is an angle that measures 90 degrees, and it's always denoted by this nice little box here. So this first sort of piece in your notes says that in a right triangle, the two sides adjacent to the right angle is known as the blank or the blank and blank. So adjacent means next to or touching. So if I look at the two sides of this triangle that are touching the right angle, I'm specifically talking about this side and this side. And these are called the legs of the triangle. So this is a leg and this is a leg. And typically when we talk about the Pythagorean theorem, they are labeled as A and B. So I'm going to go ahead and call this side A and call this side B. I could very well switch this up and call this side B and this side A. They are pretty interchangeable because they are both legs. So here's my A and my B, leg A and leg B. If I look here, the side that's opposite from the right angle, so if you draw an arrow through the right angle box directly to the other side of the triangle, this is called the hypotenuse of the triangle. So hypotenuse, the hypotenuse of the triangle, or this is also called my C value. So here's C, and this is my hypotenuse. So I have a leg and a leg, which are the sides of the triangle that are attached to the right angle, and the hypotenuse. And the hypotenuse is always the longest, the hypotenuse is always the longest side of a right triangle. So it's always the side of the triangle that measures to be the longest. So the Pythagorean theorem tells us how the blank lengths of blank triangles are related. So the Pythagorean theorem tells us how the side lengths of right triangles are related. So it's really important that we know that the Pythagorean theorem only works for right triangles. So in any right triangle, the length of the hypotenuse is equal to the sum of the blank of the other two sides. So the sum of the square of the other two sides. So more simply stated, we can use this formula: A squared plus B squared is equal to C squared. We could also say that leg squared plus leg squared is equal to hypotenuse squared. So this A squared plus B squared equals C squared is really important for when we're going to solve some of these problems down below. So I'll scroll down a little bit. Here it says label A, B, and C on each of the right triangles. So A and B are pretty interchangeable because they're both legs of the triangle. But for C, it's really important that we make that arrow through the box and across to the other side. So here's my C, and whatever's left over I can call A and B. So again, through the box, here's my C, and we can call this B and A. And through the box, here's my C value. I can call this A and B. And through the box, here's my C value. I can call this A and this B. So here, we use the Pythagorean theorem to find missing side lengths. So again, you can write this here, A squared plus B squared equals C squared, although you can probably see it because it's still just above on your papers. So the first thing that I'm going to do is label my triangle. So here's my C, we can call this A, and we can call this B. So using my Pythagorean theorem, so I want to see this in your boxes. I'm first going to write A squared plus B squared equals C squared, and then I'm going to go ahead and fill in what I know. So 3 squared plus 4 squared is equal to C squared. So 3 squared is 9 plus 4 squared is 16 is equal to C squared. So I know that 9 plus 16 is going to give me 25 is equal to C squared. So now, since I want to know what C is, I can go ahead and take the square root of both sides. So this is digging back to a few weeks ago. Remember when we talked about Cheez-Its? Then we talked about square roots. So if I take the square root of both sides, this makes this square go away, and the square root of 25, we know that 5 is equal to C. So here, this side length of this triangle is equal to 5. So let's go ahead and try another problem. I'm first going to label my side. So there I have C. We can call this A, and we can call this B. So in A squared plus B squared equals C squared, I have 24 squared plus 7 squared is equal to C squared. So 24 squared is going to give me 576 plus 7 squared is going to give me 49 is equal to C squared. So 576 plus 49 is going to give me 625 is equal to C squared. And again, I can come in here and take the square root of both sides so that I can get rid of this. And I'm left with 25 is equal to C. So this hypotenuse right here is 25. It measures to be 25. And another example over here, we'll start by labeling my triangle. So through the box and to the other side, I'm at C. Let's call this A and this side B. A squared plus B squared is equal to C squared. Oop, I did not want that to turn into the highlighter. So 7 squared plus 12 squared is equal to C squared. So 49 plus 144 is C squared. And I know that this is going to give me 193 is equal to C squared. When I take the square root of both sides, here I get that, here I have round to the nearest tenth. So I have 13.9 is equal to C once I go ahead and take the square root of both sides. So this side length is 13.9 feet. Here we have centimeters, and here we have inches. Awesome. So here what I want you to do is find the missing side of each triangle and round your answers to the nearest tenth if necessary. So I'm going to just go ahead and label these triangles with you. So here, this will be my C value. We can call this A and this B, so let's go ahead and set it up. A squared plus B squared is equal to C squared. So 4 squared plus 9.9 squared is equal to, and we can say x squared if we'd like, or we can go ahead, if we don't want to confuse ourselves, call this C squared, and just know that this is the missing side length that I'm searching for. So you can go ahead and evaluate that. This over here, if I make my line through my box, this is my C value. So let's go ahead and call this A and this B. So A squared plus B squared is equal to C squared. Or A squared plus 10.4 squared is equal to 12.3 squared. So now I'm searching for A. That's the side length that I want to find. So what I want to do is I want to figure out, I want to move this over. So let's subtract 10.4 squared from both sides, and I end up getting that A squared is equal to 12.3 squared, which is going to give me 151.29 minus 10.4 squared, which is going to give me 108.16. So 151.29 minus 108.16. This is going to give me an A squared value of 43.13. And we know that we can take the square root of both sides. So when I do that, I get that A is equal to 6 and we're rounding to the nearest tenth. So 6.6 is what my A value is equal to. A is 6.6. So this one is really similar over here. We can call this A. We can draw my arrow through the box, call this C, and we can call this side length B. So I'll let you do this last one on your own over here. So I'll highlight this so that you know that you can go back and do that one on your own. Then we say we can reverse our thinking too. So the Pythagorean theorem holds true for every right triangle. So we can tell if three sides form a right triangle if they work in the Pythagorean theorem. And remember that the longest side is always the C value, which is the hypotenuse. So here's an example that I have for you right here. It says, do the following side lengths of a triangle form a right triangle? So if I had a triangle with three side lengths of 8, 15, and 17, I would know that since 17 is the longest, this is my C value. So we could go ahead and call this A and B. So does 8 squared plus 15 squared equal 17 squared? And yes, it does. So these side lengths do form a right triangle. So if I look at this problem that I want you to try on your own, I would label 11 as my C value. We could call this the A and the B value. I would label 16 as my C value since it's the longest. And we could call this A and this B. I'll just have you go through and follow the same steps that I did up here in this example, and I'll have you do these last 4 problems. And when you finish, I have an answer key for you, and you also have a practice sheet for homework tonight. So we will chat a little bit about the Pythagorean theorem when I see you next in class. Good luck with these problems, guys.